larger the better.
This. Okay. Welcome tonight. Most of you know tonight should be Kai's presentation, but he can't make it today, and I don't want to reschedule it again. So please excuse me if I have to post.
11:57.
Okay. Okay. Get another password.
11:57, not 11:57.
Okay. Can you guys try it?
Is it different?
It's the same password. 11 without A. Jonathan, do you want to introduce your firm? We have full house, guys.
Sure, absolutely. So we're very happy to host this meetup. We've been having problems with our internet, as you guys can see. We're Place IQ. We're a geospatial analytics platform. So we divide the United States in these 100-meter by 100-meter tiles. We ingest all kinds of data. We cleanse it, we normalize it, and then we build audiences out of that, which you can sort of think of as the statistical distribution of the likely type of person in that tile at that time. And like a lot of companies in New York, startup companies, the first vertical that we're working in is mobile advertising. That's where the lion's share of our revenue is coming from, but we think that this geospatial platform has a lot of applications in other verticals that we're currently exploring. And we're always hiring. So we're looking for engineers, we're looking for data scientists, looking for salespeople, account managers, ad operations people. In this group, I mean, I think probably most people are more interested in engineering and data science. So if you go to our homepage, we have a list of positions. We're hiring sort of the full stack on the data science side, from reporting analysts to machine learning experts. So have a look and welcome. And I wish we weren't having any problems with the internet, but our IT guy just left. I'm a data scientist. I don't know how to.
No, I know that. You just don't have time to do it. Okay, cool. So, how many of you have used this package in the past? Had a look. Do you know how many of you have used R part in the past? R part. How do you like it? It's good? But do you have trouble to do cross-validation? Like, do you need to write your own wrapper function? Yeah. Okay, today you will find a solution and your life will be much easier. So the reason we want to use this package, Caret, is it has a lot of wrapper function. And if you want to do visualization, visualization is a good way to explore and clean your data. And you need to do mapping, transform on the data. So it's called preprocessing. Caret has a lot of function to help you to do this. And if you want to do training, validation, test set, usually you need to write some random function and attach the random number to your dataset. This index to decide which one is training, which one is test. But Caret has their own splitting function. It's super awesome. Also, it has it's a wrapper on the top of R parts and the neural network decision tree. You just type what type of method you want to use. Also, it helps you to validate performance across all the models and give you an average model estimation. And they also tell you how important this variable were. No, it's better than that. You will see it. And feature selection is used when you have high dimension data. For example, if you have 500 variables, how usually it's hard to select them. If you do stepwise and jump one out, jump two out, it's going to be a lot of work. Also, Caret allows you to do parallel processing. It's great if you have to do high volume computation. This is a flow chart for standard process of data mining. So first page, this part. Usually when we start our data mining project, the first step is to sit down with the people who have domain knowledge. They tell us how they get the data, a summary of the data, how sparse the data would be, and the numerical data and the categorical data, and how does the data relate to the business. So the first meeting is very important. Know what's going on in the business. It's the business understanding part. It's here. So after you meet them, if you are not a domain person, you will do some research and try to come up with some operation on this. Okay. Oh. So this part including how to do imputation for missing data and how can you map and transform. It's called data preparation step. This modeling and preparation usually recursive happening. Sometimes you clean and find it doesn't fit your need, and you clean again, prepare another data set. This evaluation will tell you whether the model is helping the business or not. So cool. And deployment means you are going to submit a report to like senior manager, or you will deploy it online so you can actually use it. That was the full cycle of the data mining project. Caret have the classification part and regression part, so that's how it's called Caret. And like I just mentioned, our parts can do data mining. Neural network can do data mining. Why do we want to use Caret? It helps you to do a lot of tedious work, which you have to roll function in the big loop. It makes your whole data mining flow very smooth and convenient. This is an example. That's why I asked you to share my desktop. So let me explain them step by step. First we load the data. First we load this package in this library Caret. Second line is we want to show the structure of our object. It's the iris dataset. And we want to set the seed equal to 1 because we want all the results be reproducible. And these two pre-process and predict usually they have to show up at the same time, because the first step is tell me how you want to prepare data. And the predict function will actually do the work. So it's set up and do it. No, we're not getting there yet. This is just step 1 pre-process.
So how can you predict
We haven't got there yet. Remember, we have pre-process, we do data splitting, we do the train, we do the evaluation.
What is iris mean?
Iris is a data set having 3 types of flowers.
So it's a data set.
Yes.
So what is part of the preprocessing? Give us an example. What kind of preprocessing is being done?
This one is like standardizer, normalizer
Okay.
data. But we have so many options. I will introduce each line of them step by step. So this is just an overview how you usually do it in Caret. This page will be your good friend, and the next page will be your good friend. And so we move to the data splitting part. Create data partition will return an index for you. If this data is 200 rows, and we are positioned on 75%. How many number will return? Yes, that's correct. Because we are like leaving the 50 row as testing. We're taking 150 row as training set. So actually, this in train will return a 1 to 50. It's your index. And you can test it by length of in train. And you are using this index to take which part you want to use as your train data. And the column 5 is the name of the flower. That's the training class. So you can consider training data is X, training classes is Y, and you want to do the same thing to take out your test data by using negative in train. This means those rows you don't want them. It's already taken by the training data set.
You say then there's the train data in train class?
This training data is the index.
Yeah, okay, right.
It's the index 1 to 150. And the rest part of the 50 will be left out for test data set. So basically, we get index and we take train part out, take testing part out. And 5 is the Y column. It's the flower name we want to predict.
What is the right speed?
So iris have 5 columns: sepal length, sepal wise, petal length, petal wise, and the flower name.
Okay, simplified and you do this in
Yes. It's borrowed from R. Any question?
Why do you need the one after you create data partition? Is it because it returns a list?
Yes, it's a list. And it's the list only has one element. You just take it out by double part breaking. Okay, second page is about how should you tune the model. First, we use train control function to specify it's a cross-validation, and it's tenfold.
So 10 means plus validation.
It means how many fold you want.
Okay, 10.
Yes. So anyone know what does tenfold cross-validation mean?
Helpful cross-validation. Basically split into 10 categories and put randomly for each category, something like that.
Actually, it's not random, but the main idea is correct. So if you have a bunch of data, you group them into 10 groups, and each time you take one group out, you don't model on this. Just take it out. So the first time you take the first group out, use the rest 9. Second time you take the second group out, use 1, 3, 4. Every time you take one out. And make sure you have some change in your sampling data, and the parameter of your model will change. The index is random, but in order to make sure you have tenfold, each row will cover the order is fixed. You take one out, take the other one. Every time you use 9.
But there's no replacement.
You can specify replacement equal to true or false.
Can this be done?
You can put a random number here, right? Is that what you want? So you mean you want certain numbers in your phone? Like you want 10, 20? Uh-huh. You can define array or list to access how many folds you want at certain point. Right? If you have an array of 10, 15, 100, you can just see when I should use 10, when should I use 100 for the folder number, right? Any question? Okay, so Since this one we are using decision tree. Decision tree parameter is complexity. This dot is quite important. You should always include it if it's a parameter for your training method. So right now we want this model to test 0, 0, 1, 0, 0, 5, 0, 0, 1, 0, 0, 5 as the complexity parameter for your decision tree. It's just like using the R cards to do decision tree and feeding the parameters. It's like I'm giving the channel to define what kind of tuning parameter it will be plugged here. And R cards here means I'm going to use decision tree as my training modeling method.
So now, you got this data analyzing data and task.
So method specify what you want to use. In this case, it's decision tree. And decision tree's parameter is CP. It's complexity level. So in order, this is the fixed assignment. So you always add a dot before the parameter to show its parameter passing to the training model. So sometimes if you run into error, you're missing a dot there. Okay, so let's keep moving on. This is the train. You specify where is the x, where is the y, where is the method. How will you do the resampling? This here you're using cross validation resampling. And this is your tuning parameter. Print plot twist prediction is like tell you the performance of your model. So the basic flow is you first pre-process your data. Then you split them into training, test. Usually, I will split them into 3 parts: training, test, and validate. Because if you just use train and use the training result on your test, you're missing a step. Because every time you tune your parameter, you're using all the data. You want to tune the parameter on a new unknown data set. That's why we sometimes use validation data.
So 75%. 25%.
But I usually find I don't like train test. I usually always do train validate test because I always use fresh data set to tune the model. It gives me more confidence. Like it gives me better advantage not to overthink the data. Because consider like tenfold, you only take like 10% out. The majority of data is the same. If you right. Yes, it's pretty standard. So after you pre-process, split, and set up all your training parameter, you are going to set your data mining parameter, and you are going to set the resampling method, and run the whole training process. And you have the option to print plot or matrix to see how good it's doing. I have a really good Kaggle example, so I'm just going to move on. You guys try it on your own. You should be able to just copy paste the code and run on your RStudio. So we're moving to the visualization. So from this slide, I'm going to go over all of them step by step. First is visualization. We have you can print scatter plot and box plot. The difference is marked in green. Other part should be the same. It's wrapping the lattice. This is the drawing package right beside of underneath of the plotting. It's a lattice package. So the grammar or the calling function should be familiar to most of you. Pre-processing also involves how can you convert string vector into vector vector. So if you have, usually we would do like string as vector equal to true or false to decide whether you want to have the levels among the data set. But this one, we have a function called boundary variance to help you to convert into vector. And in stats package, you also have an option called model.matrix to do the dumb variable conversion. Okay, next one is very exciting. So how many of you find sometimes you get a whole column of 1, whole column of 0, they just contain no message, no information, and you want to throw it away. And sometimes you've got 99, 1, and 1 and 0, you want to throw it away, and you don't have confidence to throw it away. And here is your chance to throw it away. It's called near 0 var. It will detect which variable is super flat, no information inside. I will return the index of the variable to you. For this one, you will notice the x4 is all straight. And what's our next about the destination of x-ray? X-ray have 2 of 0 and 8 of 1. The near 0 var will tell you where going to be the up. So MDB were equal to 3, X-ray were equal to 3 and 4. It's the index number. And you can take it out by vector. And it's a new filter. It's a new data frame, but you only have x1 and x2 in the filter. Okay. Next one is gonna be even better. So what is x2? Anyone can help me? And how about x3? Cool. Thank you for helping out. So the find correlation function will calculate the average correlation between x1, x2, and x3. First, you calculate x1, x2. It's so familiar. They are 99% similar. And x1, x3 is very similar too, about 69%. So which one should I choose? I set a couple of points here. So basically we're going to jump this one. Because this one, they were average which one you should throw out. It looks like you should throw out x2 instead of x1. So basically it works. When you do the correlation, you want to know for the two variables that are really close, which one you should throw out. This is the function to give you the index of the one you should get rid of. Super useful. So, how many of you think you should do both? Get rid of the near 0 and get rid of the linear get rid of the high correlated column. Should you just do one or just do both of them? Okay. Are you professor in statistics? So my suggestion is you should do both of them. I always find this get rid of near zero, get rid of high correlated data. So it looks so simple, but if you write this in code, it's a lot of trouble. And let's go next one. This one we have scale to bring your variable into 0 and 1 range. It's because certain data mining methods require you to normalize your data. Yes, it will like normalize your data. It will get your no. It's just like you take your minimum, maximum, and set them into 0 and 1. That's how. Yeah, it's the scale. Sorry, I have another function to transform it to normal distribution. Sorry. And anyone can guess what this is? And it's help you to imputate the missing data and using KN. You have a lot of options about missing data. How should you imputate something to take its spot? KN is one of them. And you also have option of back impute. It's bagging imputation. If you have missing data, you want to add some value for this spot. Yes. Sometimes, most of people use local average, but sometimes they also use regression average. Like if I have 6 columns, the first column is full rank. The second column missing 2 data. I want to do a regression and use the regression coefficient to fill the data. And I move to the second column. I'm using the regression of the 3 column to impute the missing data for the third column. So there are a lot of options for imputation. Okay, the PCA and the box. This is transformation. If you put PCA, you're transferred to principal component analysis. You only want the most important parameter. If you use box plots, it's transform your data to normal distribution. That's the place I should mention normal distribution. Okay, so if you use sampling, what's the biggest concern? If you have 20% 1, 80% 0, would you be worried the whole training set only have 0? Because it's random, anything can happen. Caret had a method called balancing cross validation. It will make sure you have something there. Always have 1, always have 0. And this creates data which one can rewind itself. How big is the training set? Cool, thank you. And here I mentioned two functions. First one, create example. Second one, create float. Anyone can guess what's the difference? I quite well there, but it's still hard to understand. No, I tried to do the best to help you learn. So, consider you have a data set. The first step is to sample it. Use this data for 3 times. Use this data for 2 times. You don't care how many, because you're using replacement equal to 2. Anyone can take out and put back. You don't know how many times it will show up. This is only one round of sampling. If you use create flows, it's in the middle of the story. You separate them into groups, take one of them out, use the rest part of them. So it's different type of sampling. Okay, we're moving to the scary part. Can anyone read this? I will give you exactly 2 minutes to read this. I know. It's called the radius local optimization. You want to make sure you announce that. Right. Most of the message won't propagate the previous result. That's why you won't. Yeah. We can do a benchmark if you have something there. I would love to know that. You want to have fresh knowledge and combine them. So the idea is if you can save the training model in the end. You can save everything. You can export the log, you can export how you split the data set. You can print exactly the parameter in this model. They have export function for you to use. Have you finished the reading? Okay. So first you have a bunch of them. You fix each of them. For example, I have the EC data. You have height, weight, a lot of them. Fix the weight equal to 70. So you have 10 components based on the 10 cross validation. Then you finish it. You start from fixing all the algebra. You want to know other parameters. The big loop is fixing the imputation. So this is inside. That's how it's basically constructed. In the form, when you evaluate the data set, you use accuracy rate, but you have choices. Sometimes you find all of them are really close. I want the simplest formula for my solution. I don't care this one is 1% less perform than other model. I just want the simplest one to speed up my calculation. So in the evaluation part, you can specify what criteria you want to use. Anyone else? after you get the average performance for each of the parameters, you can choose how to combine them, how to weighted parameter sets. I have more examples. Anyone know what this is? Will Johnson? So I just mentioned box Cox can transform your data into normal distribution, but it can only take number bigger than 0. The Will Johnson can convert negative data range into normal distribution. That's the only difference between them. Box Cox, the input have to be bigger than 0. Well, Johnson can take negative number. So most of this example is the same for remote data, how you process, how your function how to convert, transform the data, and to do the work by doing it. It's two choices. Either this one or this one. Yes. So, in this example, I used vacuum cube to fill in the missing data. The second section is how to split. This is that the nice column is the white column, is the one you want to make. One to it is the X column. No. Yes, I know. So we're moving to set up the parameters. Which method we use here? Which one corresponds to CP? Good memory. Thank you. Okay. We have more fancy example now. It's called repeated CV. Why do we want to use repeated CV? Anyone know? What is repeated cross validation? Right. It's like I want more. I always want more. Repeated cross validation makes your model more stable. It's like ultimate descending. So when we look at here, first we say we want repeated table, and we want the repeated table. If in this model I have 10 parameters, the total model will be 3 times 10 times 10. You have 3 parameters. So this number will give you power to stabilize your model. This is the first step. How should you train your data? And we can look at the final result. Okay, this is Caret. So let's move back and do some coding. All the slides is written in R. Most of you have seen me written this file, right? How many of you want to learn how to make this slide in R? Just you? Or will be private session? The slides is in HTML5 format. You can print this out by Chrome, print this into PDF. So let's run something. Okay, this one doesn't have output. How many of you have tried the code on your laptop? Try to run them. Okay. The printing of the tree model is really pretty. Like this one is the iris dataset. It will tell you how many samples you have, how many predictor you have, how many class you have, what kind of resembling you did. And this is the parameter telling you when you use CP equal to 0.01, what kind of accuracy you can achieve. So it looks like which one you should choose. The model choose CP equal to 0.3 as the decision tree parameter. Okay, so how does the feature plot look like? This is the feature plot, scatter plot. Let's do a box plot. So it gives you a rough idea how the data look like. It's help you to explore if there a big outlier, should you take it out? So for create,
It's about preprocessing, some kind of smart outlier removal routine or something.
what say it again?
Yeah, on the preprocessing of the package, do you have anything to do some smart outlier removal, something, you know?
I guess so, but I never really use it. It must have some outlier control. I know your email. I will write back to you.
Right.
Because I always feel scary to take things out. Okay, this is the level dummy level function and how it look like. Let's look at this one. What were NZV return? See, we only have 2 columns left because the X3 and the X4 was removed. And we want to identify where are the correlation. Right now we have X-ray 1 to X-ray. And we want to know which one you're moving. It takes out X1. So I guess x1 and x2 is equivalent because last time around this they take out x2. Okay, let's find out what they do with the linear dependency. Find me the linear ones. So we're getting rid of the x4. x4 is x2 plus x3. So you don't want. The reason we want to preprocess is most of the data mining method is not robust enough to get rid of the redundant data. Only like decision tree can get rid of non-useful data, because when you do the decision tree, the root is the most important parameter. But layer by layer, they're less important. So you can get rid of the non-important one really easily. But if you do regression, it does matter a lot. So let's see how the centering and the scaling work. So this one, it has 3 plus 3. So the median and the standard deviation was shifted a bit. That's why the maximum and minimum look like from 3 to 3. And we can use k nearest neighborhood to do the impute. So you're right, it's local impute. Depends on the distance of the points around the data point. And k nearest neighborhood can take multi-dimension distance.
Makes sense. Do they do that nearest neighbors by Gaussian kernel or just compute the distance?
They compute the distance. Okay, PCA's without. So it's telling you the first and the second parameter is the most important parameter. And let's do some balanced split. Okay. And how should we do the array sample and the array cross validation? Here is the example. This is a diabetes dataset. Anyone see pizza? Do you guys want to take a break or no?
Sure, let's do it while the pizza's hot.
Please, go ahead. What?
参与是中国人，在外语是中国来的，对不对？
哇，
中国来的，啥黑？好了，好意思啥？I'm an outlier. Huh?
To begin,
yes.
is this entire code part of the presentation that you will give us a link to? code that you're.
It's on the slides.
Okay.
So is there a second part of the lecture?
Yes.
What will be about?
We will do some exercises and try the message app. I have 2 homework for this one.
So the second part is about homework?
Yes, I will show you how to do more.
I'm not able to copy points.
Yes. No, it's on the side. No, it's on the slides is on So this is the link. Welcome.
After all those tests, and all this me and about 10 pages. It was a very stressful part of our life.